These are the solutions to Quiz 1 calculator section. Problem 1 says to enter the following data into list 1 and 2 and make a scatter plot that fills the viewing window. To enter the lists, you go to Stat, Edit, and then you just punch in the data. Once the data is entered, you have to turn your scatter plot on. So you go to second y equals, click the first scatter plot or the first option, toggle it on, pick your type, your color, and here to get it to fit to the window you have to do zoom stat, which is the 9th option, zoom 9. That fits your data to the window. If you tried to fit your data to the window by setting your window according to the values in the data, you don't get full credit. You have to recognize that zoom 9 is the way you fit your window to a scatter plot. Problem 2. I'm going to turn off my stat plot first, so I go to second, or I just go to y equals, turn the stat plot off, and proceed to question 2. Question 2 says a 10 by 20 inch rectangular piece of paper can be cut and folded to make a box by removing the squares of length x from each corner and folding the paper. The volume of the resulting box varies depending on how much you remove from each corner of the paper. The equation for the volume of the box as a function of the square cutout is height, which is x, times width, which is 10 minus 2x, because we're cutting out from both corners, times length, which is 20 minus 2x. To see a table of values for this volume function, I need to have entered this equation into y1. To view the table, I simply go to second table. However, I need to change the delta x, the increments, to 0.5. So I go to second table set, and I change this to 0.5, and then view the table again. And that is what you should have shown me to get full credit. Next, we're asked to view a graph of this function. The graph needs to be in an appropriately sized window consistent with the context of the problem. So if this is my equation, I need to consider the values of x that make sense in context. And I recognize that if I cut out more than half of the shorter side, I will have no box. So my biggest value of x couldn't be 5. My smallest value of x would be 0. So I get the domain from looking at the equation. To get the range, the possible y values, I have to go to the table. So second graph gives me the table, and I can see that from 0 to 5, those are my positive y values. These values are all positive. If I go past 5, they become negative, which confirms my first idea that the domain is from 0 to 5. So to get the y values, I look at these values over here, and I see that they climb all the way up to 192 and then they come back down. So my y values are from 0 to about 200. So now I know my domain and range, so I go to window. My smallest value of x is 0. My biggest value of x is 5. My smallest value of y, which is volume, is 0. And my largest value was 192. I'm going to give myself some headroom. And then press enter and graph. And this gives me a graph that fills my viewing window. If you did something else, then you wouldn't have gotten full credit. We went over that in class. Okay, find the volume of the box when the cutout size is 3.7 inches. You could do this simply by going to second calc value and entering 3.7. It says to express this as an ordered pair with values rounded to 3 decimal places, so the correct answer to this would have been parentheses 3.7, comma 121.212, close parentheses. That is an ordered pair. The maximum volume possible given the original dimensions of the cardboard are found by doing second calc max, and then I have to go to the left of the maximum and to the right of the maximum, and then it guesses the maximum for me. The maximum occurs at x equals 2.11 inches, and the volume would be 192.450 cubic inches. The problem asks us to express the answer to the volume rounded to 3 decimal places, so the answer we were looking for was 192.450 inches cubed. Finally, the last question, the point 144 lies on the graph of this volume function with an English sentence interpreting the meaning of this ordered pair in context. The English sentence we were looking for was some equivalent or variation of this ordered pair tells us that when the cutout length is 1 inch, the volume of the resulting box is 144 cubic inches.